Okay, so we'll start question number 3 for the day 2. It's an interesting question. The question number is 1572. It's a matrix diagonal sum. So let's open it. Okay, so it's an interesting question, and basically you can understand from the diagram that we are gonna sum to do something with the diagonals of the matrix. So let's understand the question first. So the question number is 1572. Name matrix diagonal sum. It says given a square matrix. We are given a square matrix, which is like the number of rows will be equal to number of columns. That is what is the property of a square matrix. Remember, whenever you see a square matrix, it means the number of rows and number of columns are same. See here, 1, 2, 3, and the elements inside each index is also 3. Okay. So the name of the matrix is mat. Okay. So return the sum of the matrix diagonal. We have to return the sum of the matrix diagonal. So these sum we have to return. Okay. Only include the sum of all the elements on the primary diagonal and all the elements on the secondary diagonal that are not part of the primary diagonal. He's saying only include the sum of the all elements of the primary diagonal. So this is the primary diagonal because it is the starting, right? So sum of the all the primary diagonal and all the elements of the secondary diagonal, all the elements of the secondary diagonal that are not part of the primary diagonal. Means whatever is there, whatever is similar for diagonal 1 and diagonal 2, they are saying not to include that. Like suppose 1, 5, 9, 3, 5, 7. So 5 is same now. So don't include the 5 two times. Just add 1 plus 5 plus 9, 3 plus 7. That will give the sum of the primary and the secondary diagonal. Okay. For example, the input is given 1, 2, 3, 4, 5, 6, 7, 7, 8, 9. So the output will be 1 plus 5 plus 9 and 3 plus 7. So diagonal sums are 1 plus 5 plus 9. This is the primary diagonal. And this is the secondary diagonal that is excluded of primary diagonal number 5. So if we sum that, it will be 25. Similarly, if you see this is 4 into 4 matrix. So 1, 1, 1, 1, 1, 1, 1, 1. So what is common between primary and secondary diagonal? These are common? No, these are not common. This is quite. So 1 plus 1 plus 1 plus 1, and this is 1 plus 1 plus 1 plus 1. So there are 8 times 1. So it will be 8. Okay. So let's understand how we are going to solve this, and we'll get into it. So basically every time when we have to use the indexes, or so we have to find the number of rows and number of columns. Okay, so basically I told you to find the number of rows is we have to find the length of the matrix, which is the length of the mat. So row is equal to length of the mat dot length. This gave us the row. Now we have to find the column. To find the column, as I told, take the row and number of take the first index, or the take this 0th index and find number of elements are there in the 0 index. Here it is 3, so c is equal to mat of 0 dot length, which will give me 3, because 1 2 3 is 3, right? So column is equal to 1 mat of 0 dot length. Okay. Now next, what we have to do is initially we have to find the sum, right? So first I initiate the sum to 0. I said the sum is 0 because I don't know how many elements are there, what will be there. So as we didn't have to now see here, instead of using the general method of there are one things. Now this is a optimized answer. Okay, so instead of using 1 2 3 4 5 6 7 8 9, because we don't have to use 2 4 6 8, right? When we have to do diagonal sum, we don't need the sum a value 2486. So what we did, we just need the values of this and this, right? So we don't have to iterate over the rows and the columns because we don't have the use of all the elements. So what you can do is what I did, as I written your comment, as we didn't have to use all the element in a matrix, we chose to use only row loop. Why we chose to use the row loop? Because in row we need the primary index, we need the secondary index. So we need a primary value and the secondary value. In this also we need the primary value, and in the primary and secondary values are the same. So in this also we need the primary value and the secondary value. So we're just going to loop over the row, and we are going to use the primary value and the secondary value, and we are going to add them. So if you see here, this is the primary value, this is the secondary value. If you go to the row 2, this is primary value, this is secondary value. Row 3, primary value, secondary value. Row 4, primary value, secondary value. Okay, you'll understand more clearly when I explain you the code. Okay, so what I did, I initialized to the row. Okay, I said start from 0 of the row and increment it one by one. Okay, so what is it? Initial, I need the primary diagonal sum. So how can I get the primary diagonal sum? So okay, if you come on the left hand side again on the photo, look at the photo. What are the primary values? What you can see whenever you're trying to solve a problem, now look at what are like look at it properly, like understand the question properly and try to see what is something which is having a contact, like which you can use to solve the problem. Suppose in this case, if you see the primary diagonal, the first primary diagonal location is at 0th row, right? And the column value is 0, right? So we got the 1. Now we need the value of 5, which is primary diagonal. So if we can see, if row value increased by 1, which is in first row, it is the first column value, so it is also 5. And second row, if you see, the value of the diagonal is second and the column is also second. Okay, so what I did is, initially primary diagonal is equal to mat of I comma I. So what is the value of I? 0. So first it will be primary diagonal will become mat of I comma I. So it will be mat of 0 and 0. This will give me what? The value of 1. Now I need the second row. I need the value of 5. So how can I get the value of 5? Mat of 1 and 1. So I can do it just using the row. So that's why if you can do it with one way, no need to use the because we don't have to use all the elements, right? So we have just use the row in a way that we can get the values of all the diagonals. So that is how it is easy. You can get the primary diagonals value. Once you get the value of primary diagonal, each time you'll be getting a value 1, 5, 9. So you'll be adding it in the primary diagonal. Okay. Once you got the primary diagonal, what we did was we went to the secondary diagonal. Now we need to find the secondary diagonal. So there is the secondary diagonals are 3, 5, 7. So what is the position of 3? It's 0 row and second column. Right? 0 row and third column, which is 0 comma 2. See, in 0 array mat of 0, in 0 0 1 2, it is 3. So in second value is in 1 of 2, and it is what? 2 of 1. Okay, it is 0 of 2. And in this, okay, this is array 1, right? This is array 1. Okay, let me just write it clean so we can understand. If I just paste it, and I want you to come like this and like this. Okay, so you can see, and we're gonna put space and space. Okay, so first we need the value of what? 3. So what is the value of 3? It's in the first one. No, yes. So we have accessed this. How can we access this? By accessing the 0th and so mat of 0 of 2. So mat of 0 dot 2, which is this, mat of 0 2 will give us 3, right? And how will we get 5? Which is mat of, which is 1, which is the second, right? This is 0, this is 1, this is 1. So mat of 1, and which is the value of this? 1. We'll be getting 5. And the third value is mat of, which is what we'll be needing? 7. So it is 2 of 0. It is at 0th position, the 7. So if you see the logic around here, you can see the row value has incremented 1 by 1. I mean, the first value has incremented 1 by 1, and the second value has decreased 1 by 1. Okay, and we are able to get the diagonal values. So what logic we used was, we said in secondary diagonal mat of I, which is I value is the same because I value will be first 0. Okay, 0, then 1, 1, 2. Okay, so this value was right. We needed the I value to be 0, then 1, then 2. But the second one, which is we have to decrease 2, 1, 0, what we did was we said number of columns. So how many columns are there here? How many are there? C. How many index? So there are 3, right? So what we need the value of 2. So what we did, C minus 1. Okay, C minus R. What is the value of R here? Okay, if I see the logic, okay, so logic to get columns, what we did was we said C, which is the number of elements in a index. So number of elements in an index, which is 3, and the number of columns, which is 3, right? Minus R, what is the number of the row which is in, and 1. Okay, this is the way to get the column. So here we can see the first one, the answer is equal to 3 minus the row, which is the row? It is the first row, right? So the row is 0. So 3 minus 0, 3 minus 1, which will give 2. So we got 2. we needed 2. If you see the second one, which is like again 3 minus the row will become 1, right? This is the first row. So 3 minus 1 minus 1, which will give me 1. Here we got 1. See, we needed 1 here. We got the 1. So basically, the same way, the last one will be 3 minus 2 minus 1, which will give me 0. So that is the logic we have used to get the column value. Now we got the primary diagonals and the secondary diagonals. We got this and this. Okay. Now the what we have to do is we had a condition that the similar number which are there in the primary diagonal should not be included. So what we did here we followed increase in row value with decrease in column value. Here, as I said, increase in row value, decrease in column value. So what we did, if I is not equal to, suppose if this value, the I value and the column value are same, then I said don't add the value. If I value and C value, if I is the row value and the primary diagonal value and the secondary diagonal value are same, I said don't add the secondary diagonal. If they are not same, add the same. So if suppose primary diagonal is at the position this, okay, and the second diagonal is also at position this, I said don't add this value. If primary diagonal is here, secondary diagonal is here, add the value of primary diagonal and the secondary diagonal both. But if the primary diagonal and secondary diagonal are both at the same position, don't add the value. So that if I of I, which is the row, is not equal to the secondary diagonal, which is the this C of I minus I column, then I said sum plus of secondary decay. I have said add this value to sum. The sum will become increment of primary diagonals and secondary diagonal excluding the common element which is there in both.